This is a P5 video from the topic forces looking at the momentum equation. We can see from the brain there that this is one that we have to learn. Now, momentum is affected by two things, the mass of the object and the velocity of the object. And if we have two vehicles, one is a car and one is a truck, and they're both travelling at the same velocity, the truck has a greater mass, therefore the truck has a greater momentum. If we have two vehicles that are the same mass, but one is travelling at a faster velocity than the other, then the one travelling at the faster velocity has a greater momentum. So the question we've got, a man has a mass of 85 kilograms and a momentum of 125 kilograms meters per second. Calculate his velocity. Answer to three significant figures. So velocity, I go to my formula triangle, I cover up velocity, that is momentum divided by mass. In my equation over here, I've substituted the numbers in. 125 was the momentum, divided by 85, which was the mass, and that gives me an answer of 1.47 meters per second, and that's to three significant figures. So that's example one, a nice simple example to get us rearranging the equation, familiar with the momentum equation. Example 2. A train carriage has a mass of 25,000 kilograms and a velocity of 2.7 meters per second. It hits a stationary train carriage. What is the velocity after the collision? So we've got a situation where we've got one carriage on its own, and then carriage 1 joined to carriage 2. So let's just look at carriage 1. Okay, we need to work out first of all the momentum of carriage 1. So momentum is mass times velocity, and the mass was 25,000 kilograms and the velocity was 2.7 meters per second. That gives us a momentum of that one carriage on its own at 67,500 kilograms meters per second. Now, the momentum does not change. Momentum is conserved. Okay, so when train 1, carriage 1, locks onto carriage 2, this could be at the train station because it's not going particularly fast at all, and it's locking on to make the train longer, we've got the same momentum. So we want to find out the new velocity after the collision. So velocity is momentum divided by mass. We've just worked out the momentum and we've now got two carriages, so the mass has doubled. Okay, one carriage was 25,000 kilograms, two carriages 50,000 kilograms. So there's the momentum divided by the total mass of the two carriages, and that gives us 1.35 meters per second as the final velocity. And it makes sense, okay? We started off with a higher velocity, 2.7. It's just collided with a stationary object. Some velocity is going to be lost there. Okay, so we've got a smaller velocity at the end, 1.35 meters per second. So that's example 2. Let's look at example 3. Two ice skaters approach each other. One has a mass of 50 kilograms and a velocity of 5.5 meters per second. The other has a mass of 55 kilograms and a velocity of 1.3 meters per second. What is their final momentum after colliding? Answer to three significant figures. Okay, so first of all, both of them we've been given a mass and a velocity. So let's work out the momentum for each ice skater. So momentum is mass times velocity. So I've taken the 50 kilograms of the first person and their 5.5 meters per second, multiplied them together. So the momentum of ice skater 1 is 275 kilograms meters per second. Ice skater 2 had a mass of 55 and a velocity of 1.3. So I've multiplied those together, and the momentum of ice skater 2 is 71.5 kilograms meters per second. So they're colliding with each other. One is coming from the left, one is coming from the right. They collide with one another. So what we're trying to find out now is the difference in their momentum. Okay, so we've got 275 coming from one direction, 71.5 coming from the other direction. Okay, so the difference there is 203.5 kilograms meters per second. Okay, and in order to get that to three significant figures, I've got a 5 there, so I round up, so it's 204 kilogram meters per second. Okay, for the final momentum once they've locked onto each other. And the last example for the momentum equation. A paintball has a mass of 5 grams and it's fired with a velocity of 72 meters per second. Calculate the velocity of the paintball. The paintball gun recoils if it has a mass of 1,200 grams. Okay, so the first thing I've done here is I've converted the grams into kilograms for the paintball and for the mass of the gun. Okay, so we've gone from 1,200 grams to 1.2 kilograms, and 5 grams is 0.005 kilograms. Let's look at the momentum of the paintball itself. So we're using the momentum equation again, mass times velocity. So there's the mass of the paintball multiplied by the velocity gives us a momentum of the paintball itself at 0.36 kilograms meters per second. And that's because it's a really light paintball, okay, so it doesn't have a huge amount of momentum. Now the momentum before and the momentum after are equal, okay, conservation of momentum, there is no difference in the momentum. So if we know then that for the gun, we know the mass, 1.2 kilograms, we know its momentum, 0.36. So now we're looking for the velocity the gun recoils. Okay, so velocity is momentum divided by mass. The momentum, 0.36, divided by the mass in kilograms, 1.2, gives us a velocity of 0.3 meters per second. Now, we've got the paintball going one way. We've got the gun recoiling the opposite way. Velocity gives us a direction as well as a magnitude, okay? So we put the velocity of the gun as a minus, okay? So the paintball is going in one direction with a momentum of, with a speed of 72 meters per second, and the gun is going in the opposite direction with a speed of minus 0.3 meters per second. Okay, and because we're not just saying a speed, we're saying a velocity, we use the minus on here to represent the velocity being in the opposite direction. I hope you found that useful. Thank you.